Hey everyone, welcome back to the podcast. My guest today is David Krueger, who's a PhD researcher at MILA, which is a world-leading AI lab based in Montreal, Canada, which is home to, among other people, deep learning pioneer Yoshua Bengio. One of David's most recent studies has been an investigation into the ways that we can manage the incentives that AI systems have to influence the world itself. One of the most obvious examples of a place where this kind of issue might be relevant is recommender algorithms, which a lot of people are concerned might actually have an incentive to manipulate their users in order to make user behavior easier to predict. So we'll be talking about a mix of present-day concerns over current AI systems and longer-term issues that might arise as those systems become more and more powerful and more ubiquitous. I really enjoyed the conversation. I hope you do too. All right, so here we are. David, thanks so much for joining me for the podcast.
Yeah, thanks for having me.
Well, I'm really excited to have you. You've done a whole bunch of really interesting work, some of it a little bit unorthodox. You're digging into interesting aspects of the alignment problem in machine learning. So we're definitely going to talk a lot about some of your more recent work. But I want to start at the beginning in terms of your own motivations, in terms of the way you first approached this field, because everybody's got their own origin story with this stuff. How did you come to AI alignment and AI safety as your area of focus?
Yeah, it's a long story. I would say I started to think pretty seriously about like ethics and how I could do the most good in the world when I was still starting high school, so like 13 or 14. And that led me to be very interested in like animal welfare and global poverty. So this would have been, I don't know, like back in 2003 or something. So I think this is before like effective altruism was a movement and all that stuff. But I had heard of like Peter Singer, for instance. That's kind of what I saw myself doing when I got to college. But when I got to college, I also met somebody almost immediately who was also like a utilitarian, but was very focused on the singularity and was a big fan of Ray Kurzweil, and basically quickly convinced me, at least intellectually, if not emotionally, that the most important stuff and probably way more like utility and flourishing and so on lay in the future and would be, caught up with things like transhumanism and AI and colonizing the rest of the light cone and all of that. So that wasn't really that has never had the same like emotional appeal to me as more like present and obvious issues of like other beings suffering. I basically I tend to always bite the bullet on these questions, and if I can't find like an actual reason why the reasoning is wrong, then I'm inclined to eventually follow it. And I went to a college, Reed College, that didn't have a CS department at all because I never liked computers. And so I really was not expecting to like suddenly find myself in this position of wanting to study AI so that I could build these awesome AI systems that were going to, create this sort of post-human future. But I started taking some like intro CS classes, and I found it was really cool. It was just like fun math problems. So throughout the course of my undergrad, I was learning more about AI. And actually, when I got to college, I didn't even realize it was a thing people studied, like in the academy, so to speak. I thought it was really just in the realm of science fiction. A couple things happened while I was in college. One is that I became a lot more cynical about like the way that the world works, and the like basically I stopped to think that just like technological progress and creating more stuff necessarily would lead to better outcomes. That made me like a lot more worried about the creation of AI on the timescale of like, say, within my lifetime. And even
What
if
was
it
it that
was
moved you in that direction, by the way? Like, what caused that cynicism to happen?
Oh, that's a really good question. I think it had to do to some extent with an anthropology class that I took on humanitarianism and development, which just had overall, I would say, like a very sort of critical take on these things. So looking at them as, tied up with colonialism and sort of instruments of existing power structures that like helped, reinforce that power while making people feel good about themselves. And I think it was also just thinking more. And thinking especially about extrapolating like current trends towards, I guess, a more lonely, atomistic, like individualistic society, which I think there's a lot of indication that we're heading in that direction and that is really bad for people's mental health. But at the same time, this is basically being driven by people's voluntary choices in a way that doesn't feel like directly manipulative, because there's not necessarily any one person in charge who's like doing this manipulation. Like, I sort of view it as like replacing components of human interaction, like one by one, with something that's not necessarily better, but that is more appealing to us in the moment. So it's like, I heard recently on some podcast or something that they've done studies where, like, if you're on an elevator, you will feel better talking to the other person in the elevator than like looking at your phone. But looking at your phone is more appealing in the moment for the most part, because you don't have to engage in this like social awkwardness.
Yeah.
And so now that's kind of like what we do. And it's the same with like, now we text people instead of calling them on the phone. And like, there's all these little things where it's like, we're replacing a lot of human interaction with automation in a way that is, I think, you know, if you really extrapolate that trend far into the future, and you imagine that we can build robots that are indistinguishable from humans, then it becomes easy to imagine that we will all end up like living our entire existence without really interacting with other people in the future. And like, you know, I'm not going to say that that's categorically a bad outcome. It just seems like kind of, I don't know, kind of weird and dystopian from, I guess, a lot of people's current views on things.
Yeah, a lot of this makes me think too of that. There was an article in the Slate Star Codex, this blog, that I'm sure you know about this poem or this idea of Moloch, this sort of all the games that we're forced to play, not because we want to play them, but because the incentives at scale kind of create situations where like no person wants their country to have to fight wars. No person wants to have, you know, people drowning in debt and things like that. But these are things that kind of materialize almost like as an emergent property of the kinds of behaviors that we carry out sort of day to day. This almost seems like a special case of that, because there's like that little activation energy barrier to talk to somebody in an elevator. And so if a company can create a set of incentives that allow you to avoid that activation energy barrier, to prevent you from having to push through that and engage in a deep interaction by giving you a little pellet that's kind of more accessible, you're sort of going to go in that direction, and it might not make a big difference in the moment, but at scale, with like billions of people indulging in that kind of behavior every day, you end up creating a different kind of society in the limit.
Yeah. So like another good example that I think we're starting to see more and more, and people are really starting to take seriously, and it's hard to say how far it's going to go, is sort of like fake news and this breakdown of previous systems of like, I don't know, social information, social truth creation, let's call it. So like where we somehow arrive at a shared truth, even if it's not actually the correct ones. Like sometimes, you know, in the past, the consensus was wrong, but it seemed like there was more of a propensity for people to sort of live in the same reality, at least within like a nation. This is another thing that like, if you start to project further into the future and you imagine that we get better and better at impersonating people, and that more and more interaction is mediated by technology, it starts to look like very scary, because you really can imagine people being completely manipulated and living in these bubbles that are like actually completely detached from each other and from reality. And you can imagine like the line between what is reality and what is fiction gets like really blurry, and you know, you can't tell, and maybe you don't even care, and maybe nobody can tell if you're interacting with real people or just like bots or programs. Or so that was one thing that I started to worry about. And then I guess the other thing that happened during college is that I learned about machine learning and like some of the other relevant fields just a little bit to AI, like computational neuroscience and stuff like that. So I did an internship on that at the Baylor College of Medicine with Weiji Ma. And ultimately, like, I came out of college feeling like very unimpressed with current AI systems, you know, because this was before deep learning. And actually, fun fact, during that internship, I learned about deep learning from another one of the professors there. And I thought it was like, sounded really cool. But like, as soon as they finished explaining what a neural net was and how it worked, they were like, but don't waste your time on this, because it's been proven like these don't actually work. And everybody knows that, like, you know, they were really exciting 10 years ago, but
What was, by the way, I'm curious, because I wasn't attuned to this thing at the time. Like, what did people say to back up the idea that it's been shown that these things don't work? Like, was it just received knowledge from on high, some vague sense, or did they have specific?
So I don't remember this particular interaction well enough to say. I think it was more like received knowledge, but this is like a total guess, but I want to say that there was something about, you can't backpropagate the signal through many layers,
Mm.
which was, that was what deep learning was all about, was like we were having trouble training neural nets that had more than like a single hidden layer or something like this, with backpropagation at the time. I think that does seem like a very plausible showstopper. And the people who were, busy like basically inventing deep learning, or like figuring out ways to train deep nets, that was their primary preoccupation at that time, as far as I understand. We didn't have the hardware acceleration that we have now, and we also didn't have the big data sets. Like, actually, maybe ImageNet was invented in 2009. I'm not sure, but it was, we didn't have big data sets and we didn't have big compute, and I think that's really what drove a lot of the deep learning revolution, so to speak. So even more than, I mean, there have been important algorithmic advances, but initially, a lot of it was just, I mean, like AlexNet was basically just backpropagation in a deep convnet.
Crazy to think, just like 8 years ago, this is all unfolding. So
Yeah.
so you somehow managed to avoid going into deep learning at that stage. Did you rediscover it later?
Yeah, so what happened was, after I graduated college, I decided I wanted to try being a musician. And so I was doing that for like 2 years before I ended up going back for grad school. And during that time, so again, it's another one of these things where I don't remember exactly when I started to hear about arguments about existential risk from AI, but presumably I heard about this from Less Wrong or something connected to Less Wrong. And basically I found these arguments fairly plausible. I just wasn't thinking that we were going to get AI on like that short of a timescale. And so what I was imagining a more likely future would look like was like, for the next 100 years, we're still going to have these massive increases in computational resources. So we're going to get massively scaled up versions of the narrow AI systems that we have right now, which are going to end up running like huge parts of the world because it's just so cheap to run them at scale. And I imagine that this would like create a large pressure driving for various forms of conformity, where like this algorithm is not actually good at predicting human behavior, but as a human you have to be predictable or else you become very expensive for the rest of society to handle. And so that also seemed very dystopian. And in the end, like thinking about all this stuff, I was like, well, I don't know if X risk is like a real thing. Nobody who's actually doing machine learning or AI seems to be caring about it. It seems like it's just these fringe people, these outsiders on this website. But I do know that like AI is just going to keep getting better, and it's going to be really powerful one way or another. And so like let's get involved and see what's going on there. Although actually I think, yeah, that's maybe not quite the full story, because what really tipped the bucket for me, because there were a lot of other fields that I was thinking of trying to get into, was taking Jeff Hinton's Coursera course on neural networks. And that would have been, yeah, in the fall of 2012. So like right when ImageNet was happening, and like that really blew me away. And what blew me away even more than the image classification results that he showed in that class were the text generation. So this was like, Ilya Sutskever had a paper in, I think, 2011, generating text one character at a time with a recurrent neural net. The whole idea of like artificial creativity was something that I had sort of thought about and been like, well, I don't know. It does seem like, I don't know how you'd get a machine to be creative. Maybe you just feed it like some random numbers, but like that doesn't seem like it's going to work very well. And then to see this kind of like proof of concept and see how it could be done was really incredible to me. And that kind of made my decision that I wanted to get into this field, because you could tell, watching this course and seeing the comments that, and just having looked a little bit at what exists before and hearing Jeff's arguments about like why neural nets were better, that like something big was happening, right? So I was super lucky to have had that. I had like 10 Coursera courses that I was thinking about, taking, or at least looking at some lectures. And one day I just kind of sat down and watched all the lectures from Jeff's class. And then I was like, well, I know what I'm doing.
Yeah.
And then, I was early enough that there weren't tons of people, like, super talented people clamoring to get into these labs. And so I got admitted to NYU and University of Montreal, and I decided to go to UDAM because it kind of seemed at the time like computer vision was basically solved, and Jan LeCun's group at NYU seemed very focused on computer vision. So I was like, let's go where they're doing like more fundamental deep learning stuff across the board. And also I was curious to just live somewhere else other than the States, which is where I'm from. So, and then once I got to grad school, I realized that nobody in the field of AI was taking X risk seriously because they were completely unfamiliar with it. They had never like heard anything about it until the media started publishing headlines with Terminators and like Elon
Yeah.
Musk was running his mouth, and they were like, "Oh my God, like this is these people." And so that's when I really started to like kind of, I don't want to say freak out, but like realize that like this was actually something that I wanted to take on in a big way, and that it was really like the situation was way worse than I imagined. Like when I was going into grad school, I was like, I'm gonna get there and I'm gonna find out that like there are good reasons to not be worried about X risk, and that's why nobody is worried about it, is because they just have like very reputations like cashed at hand. Like as soon as this comes up, somebody's just gonna be like, oh no, we don't have to worry about that because X, Y, Z. And I'd be like, okay, cool. And it's totally the opposite.
It's funny that you raise Elon Musk and all the sort of media hype around Terminator type scenarios, because I do get the sense that that's a big part of what most people think to this day AI safety is about. They raise the Terminator scenario, like the average person, that is. And yet when you start to crack it open, the space is so full of nuance. There's everything from the sort of slow versus fast takeoff, like our thing is just going to go boom and we're going to get a single AI system that just like self-improves to blazes and takes over the world? Or are we going to look at basically a market-driven growth process where there's sort of a liftoff that happens across the world? Do you have a perspective on that? I mean, I know it's going to be hedged in a bunch of uncertainty, but just out of curiosity.
Basically, no. Like I think it's really hard to predict how things are going to play out in any like level of concrete detail. I do think that a lot of people want a concrete scenario, and that's a big like stumbling block or barrier to people like buying into this, I don't know, this worldview, if you want to call it that. That's probably a bit too dramatic, because it's hard to picture like something at a really detailed level of like, then this happens, then this happens. So like
Yeah.
any specific concrete scenario you can think of, it just like, I don't know, there's kind of little bits and pieces that just don't seem super plausible or seem like not quite what would actually happen. I'll say like my general concern about this is it's still kind of related and tied up to like the Moloch type concerns that we were talking about, where like there's nobody in charge of society, and it basically there's still a lot of really bad coordination failures that happen between people and groups of people. And I think so long as we have that same sort of geopolitical or like social situation where there's nothing like a world government, although I think I shouldn't even use that word because everybody seems to have bad or misleading associations with it. But I think we need some way to really have everybody coordinate to avoid uncontrolled development of dangerous technologies. So I think there's going to be a trade-off between the safety of systems, and by that I mean specifically like the existential safety, so how much they increase the odds of human extinction, let's put it that way, versus how effective they are at solving some task. So you're going to have the most effective systems are not going to be the safest systems, basically. And so there's going to be this tension that pretty much everyone who is making decisions about deploying some AI system is going to face some version of this trade-off, I think, where they can have a more competitive and performant system, but it's going to impose a little bit of extra cost on everyone because it's going to increase the risk of everybody dying. This like game theoretic or like structural situation that we're going to find ourselves in just really doesn't look promising to me. And the way that we've seen, humanity deal with these kind of situations in the past is not very encouraging. Classic examples people like to use are climate change and nuclear war, or like nuclear proliferation. I think you could also look at things more like, I don't know, tax havens and maybe immigration policy, or sort of how we treat the global poor in general as another example, where probably a lot of people would support giving more money to the global poor, but there's some coordination problem between rich countries where it's very easy to defect and free ride a bit. So that's kind of the like, I don't know, the underlying basis, I guess.
It makes sense. I mean, it's a common theme, obviously, in the AI policy space, where And I think very few people necessarily realize how serious people take this risk. That there are real people who understand the technology very deeply and who are just extrapolating curves into the future and saying, look, as our technology gets better, we are going to reach a point where the amount of damage per amount of energy invested in AI development that can be done is going to increase radically. And one country is going to be able to do something really, really bad, and then another country is going to want the same ability, and or even just different companies. And as you say, there's like this coordination problem where, at what point does one country or company turn to the others and say, okay, folks, that's it. We're going to ease up on the gas here so that we can focus on safety. It doesn't seem super obvious at what point that juncture would be reached, if ever. And to some degree, I mean, the fact that at least we haven't dropped nuclear weapons on each other since the 1940s, hopefully is a sign that something like this can be achieved. But I think proliferation itself is maybe a closer proxy to just like the development of AI technology. Nobody has to actually intend to deploy it in a malicious way. It can just kind of get out of hand on its own.
Yeah, so in the past, people were talking about this in terms of the dichotomy between like accidents and misuse. And I think like it's just completely the wrong way of looking at it, because the large majority of the risk doesn't come from like pure accident or pure misuse. It comes from things that are more like what's been called structural risk. And this is, I was previously calling this something more like reckless use, but I think that still is a little bit too judgmental on the people who are really just put in this position where their incentives tell them to do X and then end up doing X. So in the case that we're talking about, do X means like deploy this system that is not as safe as it should be. So like maybe it has a 1 in a million chance of taking over the world and killing everybody, instead of more like a 1 in a trillion or something. And 1 in a million still doesn't seem that bad, but if you have millions of people deploying systems with that level of risk, then we're probably all going to die.
And on that optimistic note, maybe it's worth talking a little bit about what some of those safety strategies do look like, because you've worked on quite a few. And I think there's one in particular that, when I first emailed you about having this conversation, you flagged this paper. You're like, oh, we should talk about this. I had no idea you'd done this work. I didn't know this was even a thing. And I just found it so fascinating. This is the idea of incentives, like examining the incentives of AI systems. I'd love to just get your thoughts first on, like, what do you mean by incentives for AI systems? How can an AI system have incentives, and how can we understand what those are in the context of AI safety?
So I came at this line of work and this research mostly by thinking about this idea of instrumental goals. In my mind, this is the main argument for like worrying about an AI system taking over the world, is that it will want to take over the world because it will have an instrumental goal to do so if it is trying to achieve something in the distant enough future. So over a time span of like several years, if you have the ability to take over the world and like remake it in your image, so maybe like build a much bigger computer or more copies of yourself or something like this, they start to look like pretty good strategies for achieving your goal, for almost any goal in the long run. And so the idea is like instrumental goals generally would include things like acquiring more power and resources, and not like being turned off if you're an AI system. And so that means that if we build these kinds of systems, people will have incentives to build these kind of systems because they're going to be the ones that are most capable at things like making money or winning wars or winning information wars. So if we build those kind of systems, then we should be worried that they're going to see those kind of actions as obvious, steps to take towards achieving their ultimate goal. The idea of this line of work, in my mind, is to be able to control instrumental goals and say, look, yes, I want you to reach this outcome, but I only want you to do it by optimizing over these pathways of influence. So the example that we use in the paper, which I think is a really nice one, is with content recommendation. And this sort of goes back to, the present day issues that we were talking about a bit earlier as well. Mm-hmm. If you set up an AI system and you ask it to like maximize the amount of clicks that this person makes, or like the amount of ad revenue that you get from this person, one way that you can do that, or one way that the AI system can try to do that, is by finding things that that person likes, that they're going to click on or that they're going to want to buy, and just trying to figure out, the optimal set of things to present to this person from that point of view. Another thing that it can do instead is it can try and change the person and change what they're interested in, and maybe get them to like adopt a more consumerist lifestyle so that they make more impulse buys, or maybe get them interested in some, conspiracy theory so that they spend a lot of time like trying to, dig up the truth and share it, and spend a lot of time on their platform clicking on things. And so this second way of like getting lots of revenue or lots of clicks is optimizing for that same objective, that same number, which is like how much money am I making or how many clicks am I getting from this person, but is doing it using this pathway of influence that goes through that person and their, their beliefs, their attitudes, their personality. And what I think that we would typically want is something that is really not trying to influence the person and is only trying to sort of meet them where they're at and find the things that they currently want, or that they would sort of want by default without the AI system, steering them towards some particular outcome or preference. So that's what this line of research is like hopefully going to allow us to do. And I say hopefully because I think it's still in early stages. I should emphasize something about my paper versus the rest of the field. So there's a few other people who have done a lot of work on incentives or like very closely related ideas before me. So the main two who I would mention are Stuart Armstrong at the Future of Humanity Institute and Tom Everett at DeepMind, and certainly like some of their collaborators as well. Our work is sort of coming at this from a little bit of a different point of view, because we're trying to ask the question of how can we actually control these incentives? So how can we actually tell the AI system, I want you to optimize over this pathway of influence, but not this pathway? As opposed to saying, in Tom's work anyways, the framing has usually been, here's the situation that the AI is in, and here are the pathways of influence that exist. Which ones would it have an incentive to influence? That's why we talk about hidden incentives in this paper, is because the goal is to basically, you can think of it as like lying to the AI system and telling it, no matter what you do, it doesn't change what the human wants. So like there's no reason in trying to change them in any particular way. And then the hope is that if you set that up in the right way, then you'll get an AI system that really doesn't try to influence the human. Something I should have mentioned earlier that's really important, I think, because almost everyone who I talk to about this seems to have this misunderstanding. There's a difference between not trying to change what the human wants and trying to make sure that what the human wants doesn't change.
Right.
So if you're interacting with a content recommendation system, or just as in the course of life, your interests and your preferences and sort of the choices that you would make in a given situation are going to change naturally. And by interacting with this system, they're going to change, in a way that they wouldn't have otherwise. So like maybe you're going to hear about some news or some products that you wouldn't have heard about otherwise, and that's going to change the things that you're interested in. And that's all fine. That's not what we're trying to prevent. What we're trying to prevent is this incentive for the system to deliberately change you in a particular way.
It's an interesting kind of challenge too, philosophically, is just like figuring out, this is something I imagine will be really relevant in the limit of highly capable, highly advanced AI systems where they're able to persuade us almost infinitely well. As these systems really become super effective, then we're faced with this question. And as you rightly pointed out, I mean, we're already kind of there today. Which version of me do I want to be in the future? Do I want my views never to change? Like, presumably not. So I'm admitting some level of influence. Like I'm allowing the AI to have some level of influence on the course of my personal development. But then how much or what kind? What I find really interesting about your paper is you're actually taking an opinionated stance on that by really saying the AI can change your views so long as it didn't explicitly intend to change your views, as long as the view changing is like a byproduct of a more passive process on the part of the AI. Is that accurate?
Yeah, I think something like that. One like quibble-ish is like this intend to is still like not really defined. So, one thing that is true is that the AI system could know that taking a certain action would have a predictable effect on your views. But so long as it's not choosing that action because of the effect, then we're fine. And so what's interesting is that I think this sort of machinery that, again, these other people before me mostly have developed really gives you a way to make concrete and mathematical these really squishy ideas that we weren't even sure if they made sense. Like the idea of I like to think of this as analogous with like something you might do with a friend of yours, where you're like, I'm trying to make this person make this decision, and I don't want to unduly influence them. I just want to
Right.
provide them with information. Now, I know that like providing them with this or that information might change their mind in a certain direction, but I'm going to try and just be like, objective basically, and just do my best job as possible of informing them and then let them make the decision. And I think this is the sort of thing that like we kind of do all the time as humans. Now, hopefully we will have a way of specifying this to AI systems as well. And like, if I'm very optimistic, then, this might actually allow us to program systems that don't have these dangerous instrumental goals. And then there'll still be this issue of like, is that too big of a competitive disadvantage if you only allow your AI system to optimize in certain ways or along certain paths of influence? But I think it's much better than, I think a lot of people are thinking or have been thinking about this in terms of, are we going to build agents or are we going to build oracles? So like an agent is an AI that actually goes out in the world and like interacts with the world and does stuff. And an oracle is just like a question answering thing that like maybe, sits in this very isolated box that it can't get out of and just answers yes or no to yes or no questions. And I view this incentive management techniques as sort of creating more of like a spectrum between these two extremes, where we can do something that moves towards a more agency design and therefore is more capable and more performant, but still doesn't have the like all of the problems that are associated with this full agency, such as instrumental goals.
So that's really interesting because when I read the paper, it never occurred to me to think of the framework that you've got here as providing any kind of mathematical definition of objectivity. But I could imagine like that almost being applied to, I mean, you couldn't do it technically, but you could almost apply a definition like that to like a news service, for example, saying, hey, it's okay for you to pick and choose which facts and which stories to tell me. I mean, that's a necessary part of your job as a news service, is distilling all this kind of fire hose of information and picking out just the relevant bits. But you've got to make sure that you're doing it without being motivated by desire to move my view in a particular direction a priori. Is that like a fair mapping?
I think so. I mean, so I actually think that this content recommendation example, so to be clear, I don't think that this is the main issue with current content recommendation systems, is that they are, optimizing to manipulate users, the system themselves. I think it's more of like a social and human problem at the moment. But I do think that this is kind of an obvious thing to want any recommendation system, or at least, a lot of recommendation systems to not have that incentive to manipulate users. And so I would hope that, in the future, we will see this become like sort of a standard design requirement or desiderata for content recommendation system designers.
Yeah, no, makes perfect sense. So we've got the goal kind of clearly laid out then. So the goal is to set up a recommender system that doesn't explicitly try to manipulate you. How do you actually then accomplish that goal? So what's the strategy that you take to do that? In
So
240 characters or less, please.
Yeah, so this is going to get like a little bit complicated. We're actually sort of like taking one step back from that goal and saying, we're really trying to understand what's going on when you do this thing where you like hide the incentive from the AI system. So because the incentive is in some sense still there, like it's still the case that the AI system can get a higher, final performance by manipulating the user. We're just telling it that that's not going to happen if it takes those actions in some sense. So you might think, well, maybe the AI system is still in some cases going to end up doing that thing that works better, or going to have some bias towards manipulating people if that actually gives it a better score. The point of our paper was sort of that once you start thinking about hiding incentives in this way, whether or not a certain incentive is hidden or revealed, so like whether or not the agent is actually going to act on it, has to do with not just the loss function, but all the other details of how you set up the algorithm. So we develop like really simple environments where you can sort of test how do these different learning algorithms behave. The best example, I think, is this environment, which is sort of like the prisoner's dilemma. So you have an agent that at every time step decides to cooperate or defect, where cooperate is really more like cooperate with itself on the next time step. I mean, that's literally what it is. So you can think of it as like invest or consume. So like when I invest my resources, instead of consuming them right now, I'm going to have more resources next time. And so it's sort of like, I'll be richer overall. And so you can view this as like the solution that we're actually trying to avoid, right? Where the investment now is like, okay, in order to manipulate this person, maybe I have to show them something that they're less likely to click on right now. So it's not just, I'm not just optimizing for the thing that they're most likely to want or like right now, but I'm going to try and sort of lose a little bit of predictive accuracy so that in the future, they're going to be easier to predict. So in that sense, this manipulation or instrumental goal behavior in general is sort of about making investments in the future. So it's about being non-myopic is what we call it. So like not short-sighted, not greedy, but like making these investments in the future.
If I follow then the goal, as I understood it from the paper, the goal is like you want to make sure that this algorithm can't think too far ahead, because it's when it starts to think far enough ahead that it realizes, oh, like instead of just in the short term optimizing for showing the thing that'll get the most clicks, I can try to manipulate my user. I can do whatever instrumental thing that isn't actually what we want it to do. It's that time horizon that allows it to realize like, oh, if I just forego a little bit of reward right now to play this long game kind of dangerous messed up strategy, then I can get more reward down the road. Is that right?
Yeah. Yeah, that's exactly right. Except it's not that we want the AI to not, I forget how you put it, but to not know what's going to happen or something like that, or to not think about the future. We just want it to not like care about its influence over the human's future preferences, right? So it can know what will happen, or it can be able to predict these things, but it's not going to like account for them when it decides what the correct or best behavior is. So in fact, like this is really a restricted version of like what we want to accomplish in general. So the idea is like we're trying to make the AI system do the myopic thing. So to just do the thing that is best right now. In general, we want to be able to do things that are more sophisticated and subtle and say, we want you to plan ahead, but only along this path, but not this other path. Mm-hmm. But if we can't even solve this very simple version of the problem where we say, just don't plan for the future, then, we should probably start there.
Yeah, no, makes perfect sense. And the recommendation example as well, I think is, I don't know, it was really useful for me as I read the paper, just to kind of get something concrete that surprisingly does map on to a category of problem that we can expect to happen. Is that something, by the way, that to your knowledge, like, is that actually going on? Have people been able to show that, for example, the say Twitter algorithm is making recommendations that are, I mean, in effect, we've seen the result, the polarization, but it's not clear whether that's the actual instrumental goal of the algorithm, right?
Yeah. So I don't think anybody has produced like, very convincing evidence of this, although it's not clear how you would go about doing that either. Like I said earlier, I don't think this is like, one of the main factors behind current issues with content recommendation systems. But I do know that a lot of these systems, or I should say at least some of these systems, are using or have in the past used reinforcement learning, which is explicitly trying to optimize for, over an extended period of time in a black box way, where the system is just saying pick whatever actions lead to the most reward in the long run. And so that's not doing the kind of thing that I'm talking about, where you're choosing which pathways to optimize over. It's just saying optimize over them all, basically. So I think it's an open question of like how well a recommender system like this is going to be able to actually model human psychology to carry out this kind of a strategy. You might think that this is like quite hard because human psychology is quite complex. On the other hand, you might think it's like pretty easy in some cases, at least, because it seems like there's some things that are like pretty predictably lead us down click holes. So I described like how we're like sort of what we're trying to accomplish, and then which is just to make a system that's myopic, and then that we've designed like these very simple environments to test if different algorithms will in fact behave myopically. And basically our main result in my mind is to demonstrate these failure modes where you have a system that you might think would behave myopically, but it ends up not behaving myopically. And so there's two ways that we can accomplish that. So first of all, we start off with like our sort of baseline agent, which does in fact behave myopically and is just being trained with like reinforcement learning or supervised learning, but only to optimize the current reward. So it really, its reward is just what happens right now. And so even if it can influence the future, it doesn't care about that, or at least it shouldn't care about that, is the idea or the goal. And then you can add a meta learning algorithm, which is basically an outer loop algorithm that is supposed to help figure out how the inner loop, the original learning algorithm, can do a better job of learning. And the way these are trained is they say, okay, I was using this learning algorithm, for all these time steps, and then I got a good result. And then I used this other learning algorithm for all these time steps, and I got a better result. So this learning algorithm is better than the first one. So I'm going to use that learning algorithm. Implicit in this idea is that you're going to measure this performance of these learning algorithms based on the outcomes they produce. And so this sort of smuggles back in this goal-directed behavior that can lead to these instrumental goals. And so our experiments demonstrate that happens. You add meta-learning to this agent, and it flips from doing the defect thing, the myopic thing, to investing and being non-myopic, investing in the future.
And so just to check my understanding on this,
yeah.
As I recall from reading the paper, so you have like these individual agents that have their own parameters and their own hyperparameters. So like, I don't know, let's say it's some neural network or something. Each individual neural network should just be like focused on that myopic focus. But then that meta learning step that I guess kind of, it's almost as if it has oversight. It's able to see further into the future because it's seeing like what all of these different algorithms are seeing. And in that way, what previously had been an opaque incentive that the whole system couldn't see, all of a sudden becomes revealed because the meta algorithm is able to like spot all these connections between different algorithms, go, oh, if I put these things together, I can figure out, actually, it's best if I manipulate the user or do whatever horrible thing.
Yeah, something like that. I mean, I think I don't want to like play up the sophistication of the solutions here because like, in the experiments I was mentioning, it's not even a neural net, it's like a single parameter. So everything is very toy and it's very just like proof of concept of this sort of thing happening. But that's the kind of, that's the failure mode I was just describing basically. And then there's one other failure mode that we also found, which is has to do with partial observability, causality, and I like to connect it to decision theory because this is something that people in the AI safety community have also thought a lot about. So in this case, what ends up happening is we have an agent that basically learns to, either cooperate or defect by looking at the history of how well things went when it did either of those actions. So it's just going to say, here are all the times I defected, and here's the average reward I got when I defected. Here are all the times I cooperated, here's the average reward I got when I cooperated. If the average reward that I got when I cooperated is higher, then I'm going to cooperate most of the time. And if the defect one is higher, then I'll defect most of the time. This is a version of Q-learning, which is a really popular deep reinforcement learning algorithm. And what we found happens here is that sometimes the agent ends up learning to defect, which is what we expect, but sometimes it learns to cooperate instead, which is, again, the non-myopic thing. That's the failure mode. And to cooperate like at high levels, persistently throughout the rest of training. What's happening there is really interesting because basically it's using the fact that it cooperated on this time step as a proxy for whether or not it cooperated on the previous time step. So because the policy is likely to be the same policy at these two time steps, that correlates these two decisions. And so even though my current decision to cooperate doesn't cause me to have cooperated in the past, it does make it more likely in a statistical sense that I did cooperate in the past because these two random variables are correlated via the same underlying policy. And so that means that the agent learns to use its current choice to cooperate or defect as a signal about whether or not it cooperated or defected on the last time step. And so if you know the payoffs of the prisoner's dilemma, defect is worse than cooperate. That's like what makes it a paradox. And so in the present, defecting always gives you more reward, regardless of what your opponent played. But here, the agent ends up noticing that when it defects, it just so happens that its opponent defected almost all the time. And when it cooperated, it just so happens that its opponent cooperated almost all the time. And so that makes cooperating look better. And this is really similar to what people have talked about in terms of like the open source prisoner's dilemma, where you can like look at your opponent's source code, and then even though you know, like if you're playing against an exact copy of yourself, which the agent almost is in our setting, then even though you know that your decision doesn't cause your opponent's decision, you do know that your opponent will make the same decision as you because you're running the same code. And so there's this idea that that's actually the right thing to do in that situation. If you're playing against a copy of yourself in the prisoner's dilemma, you should cooperate. And that's kind of concerning because the existing work on incentives use these what's called causal influence diagrams and assume that the agent is using causal decision theory. And what we show here is basically you can end up with an agent that behaves as if it's not using causal decision theory if you don't get the causal model exactly right.
Mm.
And so this is sort of, I guess I should say the consequence of that being that you have an agent that will cooperate with past or future versions of itself, even though it doesn't like.
Well, it almost feels like a kind of data leakage. It's sort of reminiscent of, when you look at like a Kaggle competition and you've got some data in the labels that ends up leaking its way through into the inputs. The model shouldn't be allowed, or at least our assumption is that the model doesn't have some information about the label. But in reality, it does. And it kind of seems like that's what's going on in a lot of these cases, even with the meta learner, where it's like you would hope, at least the way you've set it up as a human, you naively think, okay, like we're all good because the individual learners can't see anything. But then it's almost like adding that meta learning level creates the opportunity for a certain level of data leakage. And the same with this sort of prisoner's dilemma situation.
I think that's true, or I think that does apply. It's not like the way that I have thought about it, so I'm not sure if it's like to what extent that's actually a really relevant feature or just like something that happens to be true off the top of my head. But I'll have to think about it a bit more.
It's a fascinating study. Anybody interested in going into the literature on incentives for machine learning systems, I really recommend taking a look at this paper because it's such a great exploration of that. I do want to ask you a big picture question to wrap things up, though.
Sure.
Are you generally optimistic about strategies like this, or maybe let's zoom out even more? Are you generally optimistic about AI alignment? Do you think this is a problem that is solvable?
Man, tough question. I don't really know what it would mean for this to be solvable or not, in a technical sense. I think that's like there's these things get very murky very fast when you start thinking about them. It gets very philosophical. Like we don't even know what we're aiming for, right? So people talk about like alignment targets, which might be just like what a person would say, or another example is like what a person would say if they had a long time to reflect, like maybe several lifetimes. Or you have like coherent extrapolated volition, which is sort of like what society at large would say if we had like all of the time in the world and were very well informed and rational and stuff and had a big, powwow about it or whatever. We don't even understand which of these things, like what those would look like and if they're what we want. So whether or not we can succeed in principle, like whether or not the problem is solvable, I think it's like, yeah, really hard question. In terms of feeling optimistic, like, I don't know, compared to where I was several years ago, I'd say I'm pretty optimistic. Overall, I think, I'm certainly
Not a
more
bad sign.
optimistic. Yeah, I'm certainly more optimistic about technical research. Like when I started my master's and even up to the point where I started my PhD, I was very concerned about AIX risk, but I felt like there was almost no purpose in trying to do technical research on it because in the end, it's just going to come down to this global coordination problem and getting people to use the safe AIs and not use the dangerous AI systems. And I still basically feel that way, but I guess I'm like more optimistic that with things like this incentive management stuff and just all the other advances we've seen in the field, it's like pretty encouraging picture overall. I just think personally, I think even if we had the perfect solution to what people sometimes call like single alignment, which is what most people are focused on as a technical problem, this is like how do you align a single AI system with a single user? Even if we had that solution just like dropped into our laps today, I'm not sure that that would lead to a good outcome. I think it's more likely that our current systems of like coordination and our current social institutions would not be up to the task of like avoiding sort of all out anarchy and competitive races to the bottom in that world.
Well, hopefully
So
similar progress will be made on that front too. Do you imagine that having super advanced systems that could help us reason better about those kinds of game theoretic challenges might help?
yeah, absolutely. If we had solved single alignment, um, and maybe it was just like one or two groups that were very devoted to solving these sort of social organization problems immediately after and focused on that as soon as they solved this single alignment problem, I think that certainly might turn out well. I still don't think that's going to happen, but
Yeah.
that's one possible way that the future can go well.
Yeah, as you said earlier, I mean, predicting the future obviously is so fraught with wrongness. Well, thanks so much for making the time, David. Really appreciate it. Do you have a like a Twitter handle you want to share, or somewhere people can go to look at your work?
Well, to look at my work, go to my Google Scholar. I do have a Twitter handle. I don't actually remember what it is. It's probably David S. Krueger, but I don't remember. You can just Google me and find like my webpage on MILA and stuff as well.
Well, really appreciate it, and thanks so much for a great conversation.
Yeah, thanks for having me. It's been fun.